Let's use these notches in a plaster mold. In my last video, I started playing around with the design from Digital Fire for their 3D printable notches. I modeled up this and the associated pieces, which are relatively similar to these technical drawings here. There's a notch, there's a spacer, there's an embed, and there's a clip. And we went and figured out what all these pieces do. And in this video, I want to replace the keys that I have in my handles using this system. So how these work is that the embed winds up being embedded in the plaster at the spot where you want your notch. I'll need one here, and I'll need one here. So basically the plaster gets poured around that. The clip is a tool that we use to position the embed while we're pouring plaster. So here's my mold for my handle. The plaster will be in this space here, and we want the embed sticking up into the plaster. To hold it in place, we'll need a hold here, and the clip gets pushed through that hole, slides into the embed, and holds it in place while we're pouring plaster. We can then remove the clip, and the embed remains in the plaster, and we can demold it that way. And then once we have the embeds in place, we want one side to be male and one side to be female. So the male side's the notch, and we have a corresponding female piece. However, the notch is too big to fit, and that's what the spacer is. So the spacer slides down in, the notch slides down on the other side, and then these can fold together like that for our registration. That should align our two molds. So I figured out how all these pieces work. I want to go ahead and try it in a handle mold. And assuming that works, in the future, I want to go ahead and put it into a vessel as well. The handles are smaller, there's less plaster, so if things leak, it will be less of a mess. There's also less notches here. I only have 2 in my handle molds. I suspect we'll want 3 or 4 in the vessels. So I think this seems like a good place to start. So with these 3D models, you can either buy the digital files from Tony as is, or you can get the CAD files, and I recommend getting the CAD files. It's because in the instructions, Tony talks about printing several different versions with different tolerances. He calls it slack. So there's a couple of parameters that are associated with the notch. There's the one that's basically the diameter of the piece that sticks out and the inside of the spacer. So these go together. And then the other dimension is the size for the embed hole, that right there. And his slack dimension, or the tolerance, basically determines how well these fit together. So in this drawing, he has 0.2 millimeters, and that's the radius, so the diameter will be doubled. And that's what I printed these on with my Bamboo P1P printer. And these are printed on the high resolution fine settings. And you can't feel it, but there's actually a fair bit of play between these two. So I did a whole bunch of tests. I dropped it down to 0.05 millimeters, so 0.1 millimeters in diameter, and these seem to fit pretty well. These really depend upon your printer and how good a resolution it is. It probably also depends upon your filament and a few other things. So while 3D printers are good, they aren't perfect, and having that little bit of tolerance in there, I think, is very critical. However, that's just for these two pieces fitting together. How does it work inside a plaster mold? That's one of the things I want to figure out. And do we need to make any other changes? So my existing shapecast handles have these mold keys built into them, and those are derived from the base plate here. They're relatively small, and they have a fair bit of tolerance built in, and the tolerance is there for similar reasons that it's built into the Digital Fire models as well. Everyone's printer isn't perfect. So to use this system here, we basically want to replace this bump and this divot with some holes so we can put in the 3D printed notches. I went ahead and did that. One of the advantages of having the step files available is that you can pull it into your CAD program and make changes. So basically what I did was I pulled in the base plate here. I then selected this surface, and I picked the line where the recess starts and the line where the protrusion starts. I selected those, and then I was able to cut off the protrusion and fill in the recess. I then made a hole the size of the clip so it could poke through. I think it's 13.2 millimeters, basically double the OD in the original designs. And I printed up a new set of models. This is the same shape as this one, only slightly bigger. I already have one of these, so I'm going to try a different size. But the critical difference here is that we now have holes, so we should be able to use the mold system. Before I get to that, I want to talk a little bit about the tolerances I have built in. These are, I forget exactly the number, but I deliberately made these so that they're loose and fitting. So these mold keys are really only there for rough alignment. You can put the mold together and it'll slide around a little bit. Exactly how much will depend upon your printer. And let me explain that a little bit more. All right, so imagine this is the recess that we want, and we're going to fill it in with plaster on the other side. So basically corresponds to this divot here, or these features here. So basically we're going to slide these together, and there's only one point where they exactly align. And it's unlikely that the print is exactly perfect. They're very good, so most likely it's either going to be a little bit too big or a little bit too small. So what happens if it's too big? Well, if it's too big, it won't sit down in there, and we'll wind up with a gap. And a gap is bad because it means that our mold pieces aren't sitting flush against each other. The notch on one side can't fit down all the way into the recess on the other side, so it's kicking it apart. That means we'll have slip leaking out between the faces, we'll have a bunch of extra flash, things like that. So too big is definitely bad. Too small, and it'll fit down in there just fine. So that means the faces will fully seat against each other. However, that means there's a little bit of play side to side, just like we have here. But really that's the only viable option. Pretty much no matter what you're going to do, you're going to have a little bit of play, and the question is how much. And that really is based upon your printer tolerances and the models and the tolerance built in. There's another example that's similar to this when we have multiple notches. So here it is in 2D, just like this, we have two different notches, they're spread apart. And it's possible the space between these may change based upon your printer as well. Maybe it's printed at a different orientation on the print bed, things like that. So we know we need the keys slightly smaller than their associated holes, but if they're too close together and there's not enough tolerance, again, it won't seat. So each one of these individually will fit just fine. It will go and seat all the way. It's smaller than the hole. But because the spacing is off, because we don't have a perfect 3D print, it will have the same problem where we wind up with a gap. That's too close together. The opposite problem when they're too far apart. Likewise, we have this gap. Slip is leaking, no good. If they're slightly offset, which is actually this one here, they're not exactly centered, they're pushed out just a little bit, it will fit and fully seat. And we'll actually have a little bit of less tolerance back and forth. So in addition to the tolerance built into any individual notch, we also have to worry about the tolerance across the mold. I think the larger the spacing, the more likely that error can build up. So I found a parameter that works good for me for these pressing together by themselves, but once we get it into the plaster, it may be different. We might need more tolerance. And this is a 1D problem. For vessels that we want to do in the future, we will potentially have several, and so we need to worry about it in multiple dimensions, and they all have to line up, not just a couple. All right, so that's the theory around tolerance and notches. It's great that it's built in, but it means you probably need to test it yourself, and in our application, we'll also see exactly what we need. As I mentioned, this is a shape cast mold. You can download this. The only difference is it doesn't have these holes in it. You can put them in manually if you know CAD. The handles come as a 4-part piece. There's this bottom base plate. There's the handle mold that fits down inside. There's a tiny little step right here that this registers against. Fully seated. And then we have the outer walls. This one has a small cutout for the feed for the handle. And this one here is solid. And there's a few registration points on the outside. This is the outside of the mold, so it's less critical, so there's even more space there. We'll use binder clips to put this together. I like taping the handle on the inside so it doesn't move. And then we'll need to put in the notch system. So I have 2 notches, so I'll need one side to be male, which is the notch, the other side to be female, which is the spacer. We'll need an embed sitting here and an embed sitting here. And then we'll need clips to go ahead and push from the back. So the idea is we take a clip and we push it in. And this is a pretty tight fit, but it works okay. And I run into the first problem. This isn't thick enough. So whatever the thickness that Tony designed into his system, my base plate's thicker. This is actually a little bit thicker on purpose, and it gets back to having space here for the notches. I wanted this to be as shallow as possible, but we need to be able to dig in, create a recess into this plate so that we can create the positive plaster notch. Since I just modified this, I didn't change the thickness of our plate, but it does mean the notch isn't not thick enough. The other thing I noticed is that this seems really delicate. So I made a revision, and I did this actually very early on. This was the ones I used in the last video. I made this flange a little bit bigger. It's both wider and thicker, and I made it a little bit taller. However, even this one, when I push it through, doesn't protrude very much. So here's the original. It's barely pushing through. The one I made from the last video, it's sticking up a bit more, but relative to the embed height, it's really just a little bit. So I made another change, and you can see relative to the original how much thicker it is. What I did was I took the original design from Digital Fire, this measurement down here, 7, and I added the thickness of my 3D print here for the handle mold, which I think was another 4 millimeters. So now when I push this through, it's protruding a fair bit. So now I have a lot more confidence that's going to be where it needs to be. So there's one. There's the other. We'll pour plaster here, and when it comes to time to demold, we can flip it over. We can pull these out, hopefully. I think that might be a little bit of a trick. Just like that. Only the embed won't fall out, it will be stuck there inside the plaster. For a shape cast mold, you can basically reuse this twice, or you can print 2 copies, which is what I did, so I can go ahead and just do 1 plaster pour. These are basically straight off the printer. I've done nothing to them besides pull them off the printer. The only real critical feature here is the handle itself. So what I'm going to do is go ahead and seat both of these, and then I'll cut off little pieces of this. This is tuck tape. It's used a lot for resin pours, for example, and it's really sticky. And so I'll just cut off little pieces and tape down inside to make sure the handle is secure. I'm going to pull. I want to make sure to pull up so that it's fully seated. Depending on the handle design, this gap can be pretty narrow. So some sort of tool like the back of a paintbrush can make sure it's seated down and then pull up around. And you want to make sure there's no gap between the handle insert and the bottom plate. All right, let me quickly go ahead and do the other one. Both of the pieces are set. I should mention that these are separate pieces, mostly for when it comes time to demolding. You can go back in my early videos when I was developing this system, and often this piece would get stuck in there. And I want them to be reusable, so splitting it was the best option. All right, so now we get into the new part. So we'll take our modified clip, and we'll seat that down in. Get rid of the old ones. And I printed enough pieces for both. And these are also old. And then next goes the embeds. These will seat down on top. Just like that. And those are all just friction fit. I think there's 0 tolerance on them, and on my printer they fit okay. One of the questions I had is, does this leak? I think these will be okay. They feel pretty tight. I'm not too sure about demolding though. And then these 4 pieces will wind up with a spacer and a notch. And then either way, vice versa. That's how I had it before. Spacer and a notch. But those don't get put in until we're done with the plaster. So we'll put those off to the side. The mold walls go on. And these are attached with binder clips. There you go, something like that. These are relatively small molds compared to the vessel, so I don't think I need binder clips everywhere. Basically, the head pressure of the plaster, which is pretty heavy when it's wet, is less. There's less force pushing down, so there'll be less of a tendency for it to find the holes. So we're all prepped on the mold side. Shapecast spits out a README with the amount of plaster and water that you need, and we're doing twice that, so I went ahead and doubled that. So I've got 0.7 liters of water, so 0.7 kilograms, and a kilogram of plaster. Basically what we'll do is we'll take the dry and put it on the wet, let it slake, mix it up, and then we'll pour. I found that sometimes there's air pockets that develop here, so let's make sure the plaster is down or it can vibrate in. This just helps break up any clumps, but it helps pace, so I just don't dump all the plaster in so we can get hydrated. I really want one of the ones with a rotating auger, but I couldn't find one of those on Amazon. If anyone knows of one there, send me a link. All right, go ahead and let that slake. It's not a lot of plaster, so I'm anticipating some bubbles. It's easier to mix up larger volumes and get fewer bubbles, but we should be okay. Let's try to pour long, thin stream. There we go. And we got some extra plaster, which is good. And I use an old brush. Try and dab around where the handle is to release any bubbles. Plaster is also thixotropic apparently. So that means when it stops being mixed, it becomes more solid, which is different than the setting. I think that's pretty good. I'll go ahead and let the plaster set. So basically the exothermic reaction will happen, we'll get up to temperature, and then it starts to cool back down. It takes about 45 minutes, and then at that point we'll start the demolding process. Plaster is getting cool, so it should be time to start demolding. While this was curing, something occurred to me. What we need to do is we're going to need to pry this up. Unfortunately, that's with the seam layers, so it's actually going to probably shear off. But going back to the original, where this is so thin, I remembered that Tony's molds tend to be one use only. Not too long ago, he posted a video on YouTube actually about his design process, and I asked about how it was demolded, and he tends to use a heat gun. So they tend to be destructively removed from the plaster. So this may be thin on purpose, so it could just break off easily. So I'm not too sure about the reusability of these and if it'll come off in one piece. The shape cast molds are intended to be reusable. All right, so we'll start by taking off the binder clips. And then next we need to remove the very sticky tape. And now for the normal shape cast molds, this would just pop straight off. However, with these clips in here, I'm not so sure. We actually might be able to use that to our advantage. We can use the base plates to pull up maybe. So either pry under here. Seems like we're going to break things. Or we can pry here and see if the force transfers. Oh yeah. I don't want to mar the plaster. All right, great. That worked pretty well. That was good too. And these can be popped out. And if I like these, I think these might be able to be part of the 3D print for the base plate. Although if they break, then you wouldn't be able to replace them. And they're pretty small and delicate. All right, and then the outer walls, these slide off sideways. So we have nice rounded off corners. And then let me clean up the meniscus real quick. There's usually a bit of an edge here. There's a little bit of plaster on the end that leaks, but this part's solid, so no big deal. All right, there we go. So now I'll go ahead and let these dry out the rest of the way. I have removed the handle insert at this point. However, the plaster is still pretty wet, so I think I'll go ahead and let it fully cure. Basically, as it dries, the plaster will get stronger and stronger until it's completely dry. And these embeds here will stay. See, they actually sunk down just a little bit. We have a little bit of flash right here. Right there, there's a little bit of flash over the surface. Yeah, this one too, but I think that will be okay. So basically we'll take out the 3D print, and then we can go back to these pieces that'll get inserted. So we'll have a male notch, the female spacer, and we can do the opposite or the same, I don't think it matters. And when they're all flush, those we'll use as our alignment points. However, I don't want to put those in just yet. We'll do that once everything's dry. That'll take a little while for me. In the meantime, I'll clean it up, and we'll come back in a couple days when the plaster is fully cured. Remove this and see how the notches work. Now that everything's dry, we can go ahead and demold the inner part of the handle mold. To that, I've been just using a pair of pliers. This is a right angle here on the plaster, so it's a little bit delicate. I've used a variety of different filaments for this. This is just regular PLA Plus that I use for all of my 3D prints in orange. I actually have a new filament coming, but it's supposed to show up a couple days ago, but it hasn't yet. That'll be a future video. And the trick is you really want to pull inward towards the middle with the handle. And if you wanted a perfect mold and didn't want to fiddle with this, you could use a heat gun and soften this, although you have to be careful with the embeds. All right, one side, got one small, tiny little chip out. And there's the other one. So if these are my old molds, they'd have a notch and a recess on the other side, and they would fit together like this. But now we can try the 3D printed notch pieces. Do opposites on the other sides. All right, so the notch piece is going down. I'm having problems with the spacer here. There we go. All right, that was pretty tight. And these sunk down a little bit far. So now we can see how it works. So one side's male, one side's female. It should just fit together just like that. All right, I don't feel any wiggle. That's an improvement. We can look down at the alignment. It looks pretty good. And then they come back apart. Cool, let's slip cast a handle and see how it does. To do that, we need some slip, which I just mixed up and put in this container here. We need our mold and a rubber band to hold the mold together. And then we just poured the slip right down into the feed. And it'll self-level, or if you're impatient like me, you can pour both sides. I then let these cast solid. So normally what I would do is I'd slip cast a bunch of pots at this point. The pots take about 25 minutes for the ball to form, and then I dump them out and let them firm up, and I let the handle sit for that whole time. So usually in total, I give my handles about 50 minutes to go ahead and cast solid. So for the test, I think we'll just come back at that point and we'll see how we did. Our handle should be set now. You can see the level of the slip has dropped inside. Basically, that's how much water was absorbed by the plaster. At this point, I like to go ahead and drain out the excess slip out of the end of the handle. It doesn't really matter, it's just so it's less messy. Basically just like that. Now we can demold the handle. And what we're looking for basically are the two halves aligned. Have they shifted relative to each other? That's what the notches should help with. All right, filter release on that side. Same. There we go. That looks pretty good. Got a little bit here where the plaster chipped out, but otherwise looks good. So you can see the little bit of flash that we got. So this looks really good. I'm gonna set this to the side. I want to do one more test. So let's clean off the mold. Sponge it down. Get rid of any clay. All right, so the other thing I want to do is I want to go ahead and try lapping the faces here. I didn't notice this at the time, but when I was editing this video, I actually did notice that we do have a little bit of a warped plate. So it's probably less than a sheet of paper, but it's barely going back and forth. I think by the time we put on the outer walls, this probably straightens out. However, it may have transferred into the face of the plaster. And the reason this happens is that there are stresses that are in the plastic as it's deposited. If you ever have a print lift off of your bed, that's basically the same thing going on. This one adhered and is actually really, really good, but we do have a slight discrepancy here. So compared to the original mold, one of the advantages here is that we can lap this, and it's because we can remove this piece here. So let me pull out the male pieces, the notches. All right, there we go. I don't think removing those and putting them back in is a good idea. I deformed this one just a little bit. I think it'll probably still work. So what I want to do is sand these flat. So we got a big piece of sandpaper here. This is 220, I believe. And I'm going to use the surface of my bench. Make sure it's clean. And just a little bit of water so we don't kick up too much plaster dust. I'm going to take this, flip it over, and sand it just a little bit. So if we look at the original, you can see there's this very fine texture from the 3D print that transferred over. So I basically just want to sand this down so it's nice and smooth. Just checking it, it's taking off most of the texture. You can still see a little bit here. Let's go a little bit more. And just very light pressure. All right, so that looks really good. Probably hard to tell, but oh yeah, it's very smooth now. Look at them side by side. So there's a little bit of a texture here versus this one. All right, great. That looks and feels very smooth. So what that means now is that these faces should really fit together. So if you look down in there before, we might have had a tiny little gap, but now it seems to have really closed up. And we can reinstall the notches. Make sure they still fit together since I took it out and deformed it a little bit. Yep, no problem. Put the rubber band back on and let's try it again. Normally I wouldn't slip cast back to back, but this is just a test, so it should be just fine. Same deal, go ahead and let this sit. Not using this one, so they can just hang out and dry. And now what we're looking for is if the flash between the two halves got better, in addition to our alignment. There we go. So far we have much less flash, only the little spot that chipped out. And here we go, side by side. So this was the first one before lapping the face, and here's the second one afterwards. And I actually don't see a ton of difference. Oh, there's the seam on the inside of the first one. And on the inside of the second one, I think that is a little bit better. I think this seam here is actually a shift between the two halves of the mold. And that either comes down to, so that could be the mold keys not being precisely aligned still. However, that is very minimal flash, and I think being able to lap those faces is probably a good thing. I think this one came out of the mold really well, but I've had others that are definitely more warped, and being able to lap those faces I think would be very useful, which is impossible with the built-in mold keys. The clips seem to work okay. They were strong enough, and while it looks like we didn't quite seat flush with the embeds, it seems like that wasn't a problem, at least for the handle, with just these two notches. I was a little worried that plaster might leak around the embed and the clip and come out, but that also seemed to be okay. I do think it'll be something to look out for. Or it could be 3D printed into the bottom plate itself. The trick there is dealing with all the tolerances. If it winds up being that we need different size pieces for different people's printers, then that wouldn't work very well. And as far as the inserts, I think the spacer could actually be part of the embed as well. I think the advantage of having it as a separate piece is it's delaying the decision about which part you want to be male and female. And if for some reason you mess it up, I guess you could fish it back out of here. For a 2-part mold where they just come straight apart like this, it's no problem. But if we get into 3 parts, this isn't a real mold, but for instance, something like this, we'd have to pull the bottom off and then the sides. So there, getting the order right is important. So I suspect that's the reason to keep the notch and the spacer separate, is that you can go ahead and only insert them once the mold's together and you know exactly where things are going to go. I think the next thing to do is to go ahead and try making a vessel mold using the same thing. See if we run into any new problems or if it works the same way. I'm not too sure this was a huge win, but it seems like a small quality of life improvement. Hope you found that interesting. If you have any questions or comments, let me know. Thanks.